got a bottle of Patron and some lights off, 2 red devil looking eyeballs, and I finna turn up when the night falls. If you hear a siren, then it's my fault. Jump in my whip, baby, let's ride. We ain't gonna stop at a red light, and I'ma take shots like a Tech 9. It's gonna get live. Here we go, it's about to go down. Let me know, I'ma buy another round. Get low, drop it down to the ground. Oh yeah, wow, shorty make it bounce. Mama see the put cuffs on my cardiac. Took my breath away like a heart attack. And I'ma spend every dime and my money back. Everybody wanna know. If you're ready, let me know. Let's go. If you're ready, let me know. Let me know. Let me know. If you're ready, let me know. Here we go. Let's go. I got a bottle of Grey Goose and ice cubes, type of drink that'll put me in the right mood. 80 proof's gonna lower my IQ, and I've been the same way since high school. I look shorty right in her brown eyes. She about to take a trip to Cloud 9. I'm the man, baby, I get the crowd hype. I turn the cadence of a hook into a soundbite. Here we go, it's about to go down. Let me know, I'ma buy another round. Get low, drop it down to the ground. Oh yeah, wow, shorty make it bounce. Mama see the put cuffs on my cardiac. Took my breath away like a heart attack. And I'ma spend every dime and my money back. Everybody wanna know. Let's go. If you're ready, let me know. Let me know. Let me know. If you're ready, let me know. Here we go. Let's go. I got the juice like a snow cone, ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco, make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stops.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my style.
No time for daydreams. All my brothers get money, we call it gangrene. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top 2. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and they colossal. Black trader black, she messiah to the misfits. Run circles round these rappers till my shit splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stops.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my strong. she 100. Gets everything that she wants in abundance. Knows how to be a lady in public, but she can get crazy. Ooh, I love it. She got a lot of weight in her luggage, and shorty ain't bluffing. She might snap on you like it's nothing. Everything I thought I knew is redundant.
Explosive temper, I hear smoke detectors. If I don't surrender, she might hold a lecture.
Every apology's a token gesture. I'm sorry, baby, I don't know no better. You get mad when I show no effort and turn the summer into a cold December. Cruise on the high road, dodging the potholes, tied up and I'm blindfold. She got me going psycho. I walk on a tightrope, my feet getting ice cold, my head spinning like a cyclone. She got me going psycho.
Damn, girl, you got me going. Damn, girl, you got me going.
Hold up, baby, I got CBD. Now we should kick back, pop in a DVD, yeah. Baby, we should keep the peace before one of us blows up like TNT. Let's go. I guess I'm crazy too. Not right in my mind, but I play it cool. A lot of emotions I convey are cruel, and my toxic traits are like deja vu. Ooh, that's the way I do. I'm a hot mess. Face the truth. I don't mean everything I say to you, but I know that I got you going crazy too. Damn. Cruise on the high road, dodging the potholes, tied up and I'm blindfold. She got me going psycho. I walk on a tightrope, my feet getting ice cold, my head spinning like a cyclone. She got me going psycho.
Damn, girl, you got me going. Damn, girl, you got me going.
Let's go.
Alive can't put me in a box. I redefine any definition you got. I am the tiger, I'm making steps to the top. The flames, I whip it up, you just gotta hand me the rock. Take a seat, you cannot stand it. All I know, the flow harder than a Scotch bonnet. Don't try studying me, you cannot manage. This ain't what you want, bitch, I'm a fucking phenomenon. This ain't what you want, bitch, I'm a fucking phenomenon.
Yeah, you better listen. I'm bringing heat, you'll be a fan when I start rapping. Way I'll have your fucking head spinning. I'm known as spit vicious. Release bombs and go tick tick. Boom, you blow me, that head missing. I'm a phenomenon. Stacking cheese like it's Parmesan. 8 different flows, call me Octomom. I'm moving fast like the Autobahn. And I'm independent, so I'm not your fucking starving like it's Ramadan. Sick, twisted, gifted. Can't copy, printed. Can't hold me down. I shape shift, I'm liquid. I killed this beat, I might get convicted. They know how I move, it was predicted. Persistent, spoke it into existence. So consistent, no assistance. Hear me once, become addicted. If I rap it, then I live it. There's no cap, and I'll be breaking this.
This ain't what you want, bitch, I'm a fucking phenomenon. This ain't what you want, bitch, I'm a fucking phenomenon. sound. Call the corner up, no needed medical. Twin 9 millies identical. Goons in the back, God send them through. One phone call, got the squad coming soon.
I be strapped up with the top down. 100-round stick making drum sounds. Got them like, what? Playing dumb now. Gotta mask up cause it's up now.
Gotta mask up cause it's up now. 100-round stick making drum sounds. Stay strapped up with the top down. Drop 'em on beat, going dumb now. Yeah. Yeah, I ain't never seen a hitter like this before. Hit the floor before your ass hit Whitney notes. Turn them into singers, working out my index finger. Crash them at the traffic light, then I'ma hit the blinkers. Headshot, no brainer, that's a quick thinker. If you on some gangsta shit, then I'ma link with you. I'm the captain of the boat, but I sink hitters. Cameras flash and just smile for your last picture. Catch me sipping on that gas out of glass pitcher. Turned up, better hope you got your mask with you. Hit man, get him checked off the task quicker. 6 foot strapped up, ready to roll with you.
I be strapped up with the top down. 100-round stick making drum sounds. Got them like, what? Playing dumb now. Gotta mask up cause it's up now.
Gotta mask up cause it's up now. 100-round stick making drum sounds. Stay strapped up with the top down. Drop 'em on beat, going dumb now. Yeah.
Homie, day and night. Got the party jumping, about to break the ice. Stay up on my grind, that's my way of life. I got tunnel vision, I'ma chase that ray of light. And when a Filipina tells me Malakita, I put 2 and 2 together like a ballerina. This music is more than a paycheck, no money in the bank cause I make sense. I put in work till I'm brain dead. I spit a fast soul like a break next, and the car goes wild, AM, mayhem. We get it poppin', homie, day and night. Got the party jumping, about to break the ice. Stay up on my grind, that's my way of life. I got tunnel vision, I'ma chase that ray of light. I'ma buy another round. Get low, drop it down to the ground. Oh yeah, wow, shorty make it bounce. Mama see the put cuffs on my cardiac. Took my breath away like a heart attack. And I'ma spend every dime and my money back. Everybody wanna know. If you're ready, let me know. Let's go. If you're ready, let me know. Let me know. If you're ready, let me know. Here we go. Let's go. I got a bottle of Grey Goose and ice cubes. Type of drink that'll put me in the right mood. 80 proof gonna lower my IQ. And I've been the same way since high school. I look shorty right in her brown eyes. She about to take a trip to Cloud 9. I'm the man, baby, I get the crowd hype. I turn the cadence of a hook into a soundbite. Here we go, it's about to go down. Let me know, I'ma buy another round. Get low, drop it down to the ground. Oh yeah, wow, shorty make it bounce. Mama see the put cuffs on my cardiac. Took my breath away like a heart attack. And I'ma spend every dime and my money back. Everybody wanna know. Let's go. If you're ready, let me know. Let me know. Let me know. If you're ready, let me know. Here we go. Let's go. I got the juice like a snow cone. Ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stops.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my style.
No time for daydreams. All my brothers get money, we call it gangrene. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top 2. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and they colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers to my shin splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stops.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my style. scale 1 to 10, she 100. Gets everything that she wants in abundance. Knows how to be a lady in public, but she can get crazy. Ooh, I love it. She got a lot of weight in her luggage, and shorty ain't bluffing. She might snap on you like it's nothing. Everything I thought I knew is redundant.
Explosive temper, I hear smoke detectors. If I don't surrender, she might hold a lecture.
Every apology's a token gesture. I'm sorry, baby, I don't know no better. You get mad when I show no effort and turn the summer into a cold December. Cruise on the high road, dodging the potholes, tied up and I'm blindfold. She got me going psycho. I walk on a tightrope, my feet getting ice cold, my head spinning like a cyclone. She got me going psycho.
Damn, girl, you got me going. Damn, girl, you got me going.
Hold up, baby, I got CBD. Now we should kick back, pop in a DVD, yeah. Baby, we should keep the peace before one of us blows up like TNT. Let's go. I guess I'm crazy too. Not right in my mind, but I play it cool. A lot of emotions I convey are cruel, and my toxic traits are like deja vu. Ooh, that's the way I do. I'm a hot mess. Face the truth. I don't mean everything I say to you, but I know that I got you going crazy too. Damn. Cruise on the high road, dodging the potholes, tied up and I'm blindfold. She got me going psycho. I walk on a tightrope, my feet getting ice cold, my head spinning like a cyclone. She got me going psycho.
Damn, girl, you got me going. Damn, girl, you got me going. Let's go.
Take a seat, you cannot stand it. All I know, the flow harder than a Scotch bunny. Don't try studying me, you cannot manage. This ain't what you want, bitch, I'm a fucking phenomenon. This ain't what you want, bitch, I'm a fucking phenomenon.
Yeah, you better listen. I'm bringing
this ain't what you want, bitch, I'm a fucking phenomenon.
Sound. Call the corner up, no needed medical. Twin 9 millis identical. Goons in the back, God send them through. One phone call, got the squad coming soon. I be strapped up with the top down. 100 round stick making drum sounds. Got them like, what? Playing dumb now. Gotta mask up cause it's up now. Gotta mask up cause it's up now. 100 round stick making drum sounds. Stay strapped up with the top down. Drop them on beat, going dumb now. Yeah, I ain't never seen a hitter like this before. Hit the floor before your ass hit Whitney notes. Turn them into singers, working out my index finger. Crash them at the traffic light, then I'ma hit the blinkers. Headshot, no brainer, that's a quick thinker. If you on some gangsta shit, then I'ma link with you. I'm the captain of the boat, but I sink hitters. Come and splash and just smile for your last picture. Catch me sipping on that gas out of glass pitcher. Turned up, better hope you got your mask with you. Hit man, get them checked off the task quicker. 6 folks strapped up, ready to roll with you. I be strapped up with the top down. 100 round stick making drum sounds. Got them like, what? Playing dumb now. Gotta mask up cause it's up now. Gotta mask up cause it's up now. 100 round stick making drum sounds. Stay strapped up with the top down. Drop them on beat, going dumb now. Homie, day and night. Got the party jumping, about to break the ice. Stay up on my grind, that's my way of life. I got tunnel vision, I'ma chase that ray of light. Homie, day and night. Got the party jumping, about to break the ice. Stay
Hello. Hello. So, am I audible? Okay, so welcome to the session. Sorry for a delay. In this session, we are going to discuss the homework problems that was given in the last session. We also created a mashup, so you can try upon by seeing the link from the CF group. Okay, so you can try upon this problem. So we will start from the first problem. Okay, so this problem is Debu and his brother. So I advise you to first of all read the problem and give it a try. Then you can move up on the solution. So what's the problem says that we have Devu and his brother loves each other a lot, and they are given arrays A and B. And what we can do is that we want to make the minimum value of array A should be at least as much as the maximum value of the array B. And what operations we can perform is that in a single operation you can allow to decrease or increase any element of the array by 1. So that is the operation that we are allowed to perform. And what we have to make is that the minimum of array should be at least the maximum of another array B. So what we have to find out what is the minimum number of operations that Devu condition should be satisfied so that brother can play peacefully. Okay, so that's the problem. Let's try to move to the solution. Okay, so what actually is given is that we have an array which is a1 a2 till an, and another array which is b1 b2 till bm. And what we can do is that we can choose any element, any array, any element, and we can increase, either choose ai or we can choose bi, and we can do either plus minus 1. This is counted at one operation. So we have to make is like the minimum of ai should be greater than equals to maximum of bi. So that's what we want to make. Okay, so we have some array which is b1 b2 till bn, and then after the maximum of the b, the array a will start. So that means that all the elements of array A are greater than any element of array B. So that's the idea. So we have to think of some array A and B for which the cost is minimum. So what we will do, we will fix the minimum element of array A. So what we are going to fix? We are going to fix the minimum element of array A. Let's say we fix it to be x. Now we will find out if this is the value of, like, the minimum element is x, what is the cost that we are required to pay. So let's say we cost as something which is cost as a function of x. Now suppose if any ai is less than x, so suppose if any ai is less than x, then we have to perform x minus ai operations so that it become at least x. Suppose some ai is greater than x, then we don't need to perform any operation. We need to perform 0 operations. Why is it so? Because we know that all elements of B will be less than x, because x is the minimum element of array A. Similarly, suppose if Bi is less than x, then we will perform 0 operation. And suppose if Bi is greater than x, then we know that we have to reduce Bi to x, because we want all the elements of array B should be less than equals to x. So operation, we want number of operations, it will be Bi minus x. So that's the main crux. Now we can define the function cost of x as a function of x. So the cost of x would be, how we can write down the following thing. We can write down is something like, it is basically summation of max of x minus ai comma 0 plus summation of max of bi minus x comma 0. Okay, so we can write down the cost function in the following form. Now what we have seen from previous lecture is that these all are linear functions. Okay, so what we know is that these all are linear functions, and max of linear function is a convex function. So we can say that these are sum of convex function. So what I want to say is that the cost of x function is a convex function in terms of x. So now what we know is that cost of x is a convex function. So if you want to draw some graph, it will be something like that. So there would be some x for which the cost will be minimum, and that particular x, that is x optimal, we can find out using ternary search. Okay, so that was the whole idea behind that question. We fix the minimum element and then we calculate the cost in terms of x, and we find that that cost function is convex. So we can apply the ternary search to find out the optimal x. So if you see the code of that thing, that's the code. We take an element input and then we take the array as input. Now we have a function in which calculate the cost for a particular x. So it's a function which takes 3 parameters. It's x, the vector a and the vector b. And suppose if ai is less than x, then it's simply do sum plus equals to x minus ai. Similarly, if bi is greater than x, then simply do sum plus equals to bi minus x, and return the cost. And then you apply a simple ternary search here. So it divides the whole thing into the 2 points. It will be 3 equal segments, almost equal segments, and it compared the value, the function value at the 2 points, and based upon that it reduces the search space. And finally we know that upper bound lower bound need not to be equal, so we need to iterate upon from lower bound to upper bound to find out the optimal h, and at last we output the value of h. That's the optimal value. So that's simple code if you know the idea. Let's move to next problem. I think that's this part is clear. If you have any doubt, you can ask in the live chat. Okay, so let's move to the next problem, which is the maximum subsequence. So in this problem, you are given an array consisting of n integers, and you are also given an integer m. So you have to choose some subsequence of indices in such a way that the value of ABI mod m, it is not taking individual mod and summing it. It is like taking the sum and then at last taking the mod m. Okay, so it is like sum modulo m. So what we want is sum modulo m should be maximized. So subsequent exclusion can be empty. So we have to print the maximum value of the subsequent sum modulo m. Okay, and these are the constraints. N is 135 and m is like 1 to 189. Okay. So one thing is that whenever you see like this type of function, this type of constraints in which half of the constraint is like simply brute force, like we can do the brute force for n by 2 if like if n is 35, if here n would be somewhere around 20 or 15 or 17, then we could think of some brute force approach. What's the approach? Let's see here. So what I want to say is that in the question we are given the array 1, 2, 3, n, and what we will do, we have to choose some subsequence and we just find out the, let's say we choose some element ai1 plus something ai2 and so until aik, and then we take the sum modulo m and we want this thing to be maximum. Okay, so one, if we see of some brute force approach, one is simply like iterate over all subsequences of array A and find the maximum. Okay, so there's an naive approach that anyone can think of. So if you try to find out the complexity of the solution, it is like a clear O of n 2 raised to power n, because there will be 2 raised to power n subsequences, and for each subsequence on average it will take O of n to calculate the sum modulo m. So time complexity would become O of n into 2 raised to power n. So obviously this is pretty slow as n is up to 35. Okay, so here comes the idea of meet in middle. The idea is similar that we done in the previous problems in the session. What we will think is that we are given an array. We will divide the array into two parts. We will do the brute force approach for both of this part, and somehow like we will try to merge both the answers. Okay, so what we will do, we need to find out what is the maximum value of this thing. What is the maximum value of this thing? So if we need to find the maximum, what we will do, we will calculate all possible subsequent sum modulo m that can appear in the first half. So what will we calculate? All possible subsequent sum, obviously modulo m, that can appear in first half. And similarly we will do the same thing for this part also. Okay, so what we will do, we will divide the array into two parts. We'll iterate upon all the subsequences of both parts individually, and for all the subsequences we calculate the sum modulo m, and like insert into some sort of set type structure, let's say set. So we will get two sets, S1 and S2. S1 will be containing all possible subsequent sum modulo m for the first half, and S2 will be containing the all possible subsequent sum for the second half. Now suppose you want to merge this both. So what mean by merging is that we iterate upon all the elements of S1, let's say x, and we see what maximum total subsequent sum I can get if I take the x thing from the first half. Okay, so suppose I take the x thing from the first part, and suppose y, a subsequence whose sum is y modulo m from the second part. So total would be x plus y modulo m, and that should be maximum we want. So there can be two cases arise. Either x plus y is less than equals to m minus 1, or second case that can arise is x plus y greater than equals to m. So if x plus y is less than equals to m minus 1, then simply the answer would be x plus y. And if x plus y is greater than equals to m, we know that x plus y will be at most 2m, so answer would be x plus y minus m. Okay, so that only we will do. We will suppose here set S1 and S2. So for each x in the set S1 or each x in the set S2, we will first of all try to find out this condition, that what is the maximum y which is less than equals to m minus 1 minus x in set S2. So that we can do simple by upper bound lower bound, and for that part we will simply take y max and simply update the answer by this value or this value based upon which case we are talking about. So that's the idea. And now what's the time complexity now? It is simply O of n into 2 raised to power n by 2, and there will be an extra factor of log n or log n somewhere around this. So that will be time complexity, and that is for n less than equal to 35 is an AC. Okay, so that's the idea behind this problem. If you try to see the solution of this thing, the code for that thing. Okay, so what we do, we take an element input, we take the array A as input, we take S1 as n by 2, and the size of other half is n minus S1, and then what we will do, we calculate all possible subset sum for the first half and insert them into the set pre. Now we will simply iterate upon the second half, and suppose for particular subset we get our sum as h, we get the subsequent sum as h. So we know that there will be two cases. First is that y less than equals to m minus h minus 1. In that case answer will be x plus y. So we just see upper bound of this thing, and then we just to iterate a minus minus to get the value of y which is less than equals to m minus h minus 1. And if it is there, then we simply update the answer. And for the second case, if y is greater than m minus h minus 1, simply update the answer by x plus y minus m. So h, we take the y max minus m. So actually we do not need to store anything for the second half. We can just process this while iterating, and simply then print the value of our answer. So this is the code. I think this question is also clear to you. Okay, someone asked that can't we just make dp of m, where m is the modulo we can make for some subsequence. We can't do this because if you see the limit of m, it is up to 1 in 9. So making a dp state of size 1 in 9, it is not possible. Okay, so now we move to next question. Uh, the problem number F, it is lizard era thinking. Okay, so what's problem F says? In the game of lizard era, so there are 3 companions, Lean, Maligna and Worrigan, and the game has n mandatory quests, and to perform each of them you need to take exactly 2 companions. So basically there are n quests, and in each of them you can have to take exactly 2 companions, either L or M, or Melina, Worrigan, or Worrigan or Lean, like exactly 2 of them. And what we know is that the attitude of each of the companions is an integer. Okay, so the hero complete a quest and he make actions that changes the attitude of companions, and the change can be either positive or negative or 0. Okay, so we have to tell us that what companions the hero can choose to make their attitude equal after completing all the quest. And if there are several ways, then we have to choose in which that equal value is greatest possible, and n is given up to 25. And if there is no solution in which we can make all 3 of them equal, then we have to print the answer to be impossible. Okay, let's move on to solution. So what basically we have is that there are n quests. So there are n quests, and for each quest we have 3 parameters. Li, one is Li, Mi and Wi. So it's Li, Mi and Wi. So each quest has 3 parameters, and for each quest we have to choose 2 of them, either this or this or this. Okay, and we do this for all n quests. After this, we'll calculate a total score of L, M and W. So what is score of L is that it is sum of Li for which Li was chosen. Basically, if it in a particular quest we take Li, then the L is increased by the score of Lean is increased by Li, and similarly we define M and W. So what we want is that after all n quest, all 3 scores must be equal. So what we want is that all 3 scores must be equal after the all n quests of operations are performed. Okay. Now, how we can think of the solution? The thing is that now we have for each, we have like 3 possible ways. Okay. So suppose we consider any ith quest. We have some li, wi, and li, mi, and wi. So there are basically 3 possible choices. Either we leave wi, or we leave li, or we leave mi. Okay. So if we leave mi, that means we are taking li and wi, and similarly others. So basically we have 3 choices for each of the ith quest. Now as we have 3 choices for each quest, the total number of choices would be 3 raised to power n. Okay. So this will be total choices. So by seeing this and seeing the constraints, one thing that came into mind is that can't we simply do a brute force? Like what we will do, we will create a mask up to 3 raised to power n, and for each mask of that mask we consider of length n, we have some n things. So we have some n bits, and each bit has 0, 1 or 2. Let's assign for 0 means let we skip L and takes m comma w. So that's how we define for 1 and 2 also, and we simply calculate what is the cost for L, and what is the not cost, this like what is the attitude for L, M and W, and if the 3 attitudes are equal, then we simply update the answer by the total sum. Like answer is something like max of answer comma total sum here. Okay, so that's a brute force approach. Iterate upon all the mask till 3 raised to power n. So the mask will be of length n. For each mask, it will be either 0, 1 or 2. 0 means we skip the L, 1 means we skip M, and 2 means we skip W. Calculate the total attitude, and if all the 3 attitudes are equal, then we simply update the answer by max of answer comma total answer, the total sum here. So if you see time complexity, it would be O of n 3 raised to power n. Obviously, as n is up to 25, this is again slow. So we need to optimize this. So I think most of you have thought till at this point. The idea we are going to use is similar, that is median middle. Okay, so what we're going to do, we have an array of n things. Now we will divide it into again 2 parts, and each part we will do a brute force solution. But we have to, for merging, we have to think some in different direction. Let's say for this part and for this part, suppose for this part we have some solution for which the total score of lin or total attitude of lin is L1 and M1 and W1. And let's say for this part we do a brute force for second half, and let's say we get a triplet L2, M2, W2. That is the total attitudes of lin and what are the names? Lin, Meliana and Borilin. So now suppose if this is a valid only if all the scores are equal. So L1 plus L2 is equals to M1 plus M2 equals to W1 plus W2. If that's the case, then we can simply say that it's a valid solution. Okay. So how to ensure that this condition is true? You can write down this condition as L1 minus M1 equals to somewhere like minus of L2 minus M2. Similarly, M1 minus W1 is equals to negative of M2 minus W2. Okay. Now the thing is that it is only dependent upon the first half, and these terms are only dependent upon the second half. So what we will do, we will calculate all the subsequences for the first half. Like in this case, we calculate all the subsequences for the first half, and suppose the value of L, M and W we got as L1, M1, W1. So what we will do, we need to store a pair which will be L1 minus M1 comma M1 minus W1. Like we store some map sort of thing in which the key will be a pair. So suppose we have pair L1 minus M1 and M1 minus W1. Now if you want to find a valid solution for second half, also we do the same thing, and for this particular key alpha comma beta, we need to find a complement which is minus alpha comma minus beta in the second half, and if we combine this both, we will get both of combining, we get it's a valid solution. Okay, so for map, the key will be this thing, and what will be the value? Value will be simply L1. Okay, so if we have some, let's say we create a map in the first half, and we get suppose alpha comma beta, and the corresponding value of L is let's say gamma 1. So we search for the corresponding complement part in the second half, which is a key value of minus alpha minus beta, and we have suppose the value is gamma 2. Then simply update the answer by answer is max of answer comma gamma 1 plus gamma 2, because that will be L1 plus L2, and that will be basically the total score. So that's the main logic that we can apply for solving this. We take a subsequence, we calculate the value of L1, M1 and W1, and in map for key value we store L1 minus M1 comma M1 minus W1, and value part is L1. And similarly we do for the second half, and then for alpha comma beta in the first half, we need to find minus alpha minus beta in the second half, and we can take simply answer as max of answer comma gamma 1 plus gamma 2. Okay, so let's see the code for this thing. So we take the input L and M and W. We take the first part n by 2. The length of second part is n minus n1. Then we simply we create 3 raised to power n1 and 3 raised to power n2. Then we create a map which is like the pair of int comma int comma pair of int comma int. So that's the other way we can do. like key will be a minus b comma b minus c, and the value will be like we are not storing a single value, we are storing a pair of values. That's basically the maximum value and the mask. Why we need to store the mask? Because we also have to find the string. So for that the mask is helpful and it is needed. So we simply iterate upon all the masks, and for particular mask calculate the value of like a, b, c, or like l1, m1 and w1. We create a key value of a minus b, b minus c, and we first of all see if it is not present, then we simply make this key and mask. Otherwise, if it is present but the value is smaller, then also we can update the map value. This was for the first half, and for the second half we will do like we have mask 0 to like s2, this is 3 to power n2, and we simply calculate the value of a, b and c here. Now we can say that what is the target key. Target key is basically now a minus b not, it's b minus a comma c minus b, because we know that alpha beta is mapped to minus alpha minus beta in the second half. So we have some target key, and if the target key is present in the first half, then we can simply current total is, that is the first half value plus second half value, and then simply we can update the value and the mask. So if like we create a flag variable, if it was false and it remained false, that means that we have to output impossible. Otherwise, you have to construct a string, and then we can do like we have mask, and like we can do it for the both parts. Like we have the mask, if n1, we like see what's the choice, and we can simply create a vector of strings, and then we can just append the strings like that. So deconstruction part is simple. The main logic was this part, that how we are iterating and how we are applying the meet in middle here. So if you see the time complexity of this, we have reduced the time complexity to order of n into 3 raised to power n by 2 into some log factor of, let's say, n. So as n is less than 25, it's an AC. So I think this part is clear. You can ask any doubt for this particular question. Okay. So let's move to the next question. So this is the restorer distance. You can try upon this. So let's move to solution. So what's the problem says that we have n pillars of bricks, and we have height of each pillar given to us as hi. So we have to make all the pillars have equal height, and there is some cost. The cost of putting a brick is a, the cost of removing a brick is r, and the moving a brick from one to another, the cost is m. Also, one more important thing is that you can't ignore any pillar even if the height becomes 0. So we need to find out what is the minimum total cost of restoration. That is, what is the minimum cost in which we can make all the pillars of equal height. Okay, I think the question is clear. So input is like N, A, R and M. N is number of pillars, A is the cost of addition, R is cost of removal, M is cost of moving one to another, and we are given also input as N heights of pillars. Okay. So let's see how we can solve this problem. So we have heights as h1, h2 till hn. So the heights is this thing, and you want to make all the heights to be equal. Let's say we want to make all of the height to be some, let's say capital H, or let's say some capital H. So we try to create what is the function of the cost in making all heights equal to be capital H in terms of capital H. Okay, so we call this to be something like cost of capital H. That what is the cost in making all the heights to be equal. First of all, you need to understand one thing is that moving is not always an optimal. Suppose like we have one brick here, one pillar here and one pillar here, and we are moving a brick from there to here, so that cost will be capital M. But if like capital M is less than, or suppose it's greater than A plus R, then instead of moving, it is better to like do one addition here and one removal here. Okay, that makes sense, because if A plus R is less than M, then M is just a myth. So what we can do is that we can update my M as minimum of M comma A plus R. At the beginning we can update the M so that we don't need to worry about the particular case. Okay, now suppose we want to make the final height to be, let's say, all equal of capital H. Now how I can make the final height to be capital H? We will like, there will be some pillars whose height will be less than H. There will be some pillars whose height will be greater than equals to H. Okay, so let's say for less than H part, what we do, let's say height is suppose X. We create two variables P and Q. P will be like how many bricks I need to add, that is bricks needed to add, and Q is basically how many bricks we need to remove. So P is basically how much bricks we need to add, and Q is like how much bricks we need to remove. Okay, so basically P is what? We iterate upon all the pillars whose height is less than X, and we simply do P plus equals to H minus X. Okay, so P plus equals to H minus X. And for Q, we iterate upon all the pillars whose height is greater than X, and then simply Q will be plus equals to like X is greater than H. So Q will be like plus equals to X minus H. So that's how we define P and Q. So suppose we consider two parts. Suppose case A, P is greater than equals to Q. Okay, so if P is greater than equals to Q, what will be the cost? Cost is simple. Like cost would be, like we know that number of bricks we need to add is more. So we take the Q bricks that we need to remove, and basically we move all the bricks to the places where it is needed. But as number of places where needed is more, we would be left with some P minus Q places, and at each this place we need to add a brick. So that cost will be Q into M plus P minus Q into A. Similarly, if we consider some case B, if P is less than equals to Q, so what will be the cost? In a similar way, we can write down the cost would be, like we will need to move the P bricks, plus there will be some bricks which are still need to be removed from their places, Q minus P bricks, and we need to remove the bricks. So that will be the cost. Okay. Okay, so now what we know is that for a particular height h, we know how to calculate the minimum cost. So if you try to run the function for some, let's say for some small range of values, you will actually get that the shape of the function to be convex. Okay, so what I am saying is that for a particular height h, you know that how we can find out the cost, the value of the function at a particular height h. So if you try upon some small values, you will get that initially it is strictly decreasing, and it reaches some point, and then it start strictly increasing. So that type of behavior you will see. So that certainly gives an idea that the function is convex, but that's not the proof. Proof is somewhat mathematical. You can try upon. It is based that on some height, let's say hi, and some, let's say hi plus 1, it is going to be some piecewise linear function, either this type or this type. And as we increase the height, we will increase the value of p, and we will at certain point we will reach from case A to case B, and that point will be somewhat point of minima. After what it will start increasing. So there will be long mathematical proof you can try upon, but you can see from small values that it is following this type of convex behavior. Now as the function is convex, the idea is pretty much similar. Simply apply Ternary search and you will be done. So main thing is here is that you don't always need to prove that function is convex by rigorous maths. Sometimes seeing the small values, running a loop up to, let's say 200 300 times, and printing all the values in terminal, you can get the idea upon the behavior of the function. So that's the main motive of this question. Code is pretty simple. You can see that thing. That's the same thing I tell to you. You get P and Q, total additions and removals. If hi less than h, P plus h minus hi, and otherwise Q plus hi minus h, and then we simply take the moves. So it's like a function which is calculating the cost if you want the final height to be h. Then one thing is that we take ms min of m comma a plus r, and then we apply simply a ternary search, update the values based upon functions, changing the ranges, and finally we print the answer. Okay, so that's this question. I think it's clear. If you can have any doubt, you can ask in the chats. Okay, so that's all from my part. Now I will call Karthikeya for discussing the rest of the problems. Hello, I'm Karthikeya, and I'd be discussing the problems regarding constructive algorithms. Now, I hope you have attended the last lecture and tried these problems. If you have not, I would suggest giving these problems a go. These I think you should at least give 30 minutes if you are not able to solve, and then move to the solutions. So first problem is this: minimize fixed points. So the problem statement is small. It is just you need to construct a permutation with the minimum number of fixed point, which is also good. And good permutation is defined as if the GCD of I comma pi is greater than 1 for I from 2 to n for all I, right? So like for each index, the number that you place on that index should not be co-primed to that index itself. So the problem statement is straightforward, and let's dive into the solution. Okay, so the first thing in these kind of problem, what you should do is you should just check the constraints. Like if the problem says that if this condition is always possible, then you should try and prove that this condition is always possible in constructive problem. So the thing here is you need to minimize the number of fixed points, right? So I would suggest in this problem you should try and find what that minimum number is, and what conditions you need to satisfy in order to achieve that minimum number of fixed points, right? And fixed points, if you do not know, it is basically where at the ith index you just place I, right? So when do we have fixed points in this problem? We need to satisfy the condition that GCD of I comma pi has to be greater than equal to 2, right? Like they do not have to be co-prime. So a condition that would definitely arise is when the index ends up being, that index is just co-prime for all the indices, for all the numbers from 1 to n. So if GCD I comma j is equal to 1 for I is not equal to j, and j is less than equal to n less than equal to 1, so this would definitely give you a fixed point. Like at this index you need to place I, otherwise you cannot. So if you think about it, there are only a few numbers that would satisfy this property. First is 1, and the second is if you think about, so first observation that we could draw for I is that I has to be prime. If I is composite, then we could just put that factor there. Like if I is, let's say, divisible by some p which is less than I, then we could just place that p in that at that place, and we would satisfy the condition, right? We would not end up with a fixed point and satisfy the above condition. So what we try to do here is we would just check for which primes it would be, like it would be impossible to place. So
if let's say there's a prime P, so all the numbers that it would be co-prime to, it would not be co-prime to, like whichever numbers it would divide would just be greater than equal to 2p, right? Because 2p is the first number that it would divide, that it would be it would not be co-prime with. So when can we not place 2p at the pth index? It would be when p is greater than equal to, when p is just greater than n by 2, right? When p is greater than or equal to n by 2, right? So, well, so the condition that we have from here is that p has to be prime and it has to be a prime greater than n by 2. That's actually it is. It has to be greater than basically n by. So the conditions that we have from here is basically it has to be greater than n by 2 and prime. So also that the index 1, it would also satisfy this, because 1 is GCD of 1 with any number ends up being 1, so it is always so 1 is always ends up being a fixed point, right? So from this what conclusions have we drawn? That whenever this condition and these conditions satisfy, it would be a fixed point, like there is nothing we can do. So the minimum number of fixed points has to be greater than equal to I that satisfy this condition, right? So we do end up with, so this is at least the number of fixed points that we get. So now we would try and think of a construction that always achieves this minimum number of fixed points. So if you want to give it a try from now, then I think you should pause and think about it, what construction it would be. So the construction, so the first thing that we discussed here is whenever p is prime, we could just place 2p in that, at that index, right? And whenever p is composite, we have a lot of choices. So let's just ignore the composite case for now. So in this case, what we would try to do is at prime indices we would place 2p and suppose now I would like you to suggest I would suggest that you think of permutation as cycles, right? So we do not want, so fixed points are basically cycle of one length, right? So we do not want one length cycles, and if all the indices in that cycle have to be cannot be co-prime, like no two indices in that cycle could be co-prime, that is our condition, right? So basically what we need to satisfy is that GCD of that all elements of the cycle, all nodes of the cycle have to be cannot be co-prime, cannot be 1, right? The GCD of all the nodes in the cycle cannot be 1 because like if it is prime, if the GCD of all the nodes in the cycle is a number greater than 1, then the indices would definitely divide the number, right? So what we could think of from here is that suppose we just keep on building the cycles, like keep on building the nodes, and we would just place them in the cycle, right? So so I would just like to think, I would suggest that you think of a simple constraint on how you would build the cycles. So one of the way, like there are many solutions from here on. One of the ways basically uh, you put p you put uh, you put p with 2p and just keep on, like in this cycle you keep on adding the elements such that highest prime factor of n is equals to p. So you would end up with an array of elements which you could just keep on adding the edges, which like just to visualize, you could add the edges and it would be a cycle, and you could just throw it in the permutation and it would satisfy all the conditions, right? So you just in this case you just need to keep on creating cycles, and each individual cycle would end up being just these numbers, right? Like the prime with all the numbers such that highest prime factor is n. Now why are we not using the smallest prime factor here of n, like mapping, like putting n in the cycle of the one with smallest prime factor, right? So it is mainly because if you do it like with using the smallest prime factor, you would end up with elements which do not have a cycle, and they would just end up being fixed points, like they would be just a cycle of y. So we do not want this. We have already proven that like this method helps us achieve the minimum number of fixed points. So this is obviously the optimum. So our solution just ends up being like this, that you create an HPF array where you could just use a simple sieve of complexity n log n and get the highest prime factor sieve. And what you would do is you would just create a cycle. You would just create for each index which is still empty, like for each index which is still empty, you would just create all the elements which would be in that cycle. You just go ahead and find that. You could just do it by iterating from 1 to, like from p to n, but at strides of p length itself. Like you go from p to 2p to 3p and so on, and check whether the HPF of this number is equal to p and just add it into the cycle. So this would reduce so it is basically brute force, but it would reduce our complexity to n log n. So basically with this idea you could the implementation becomes much easier, and you could just, after you have the cycles, let's say you have 2 with 4 with 8 and like this, so you could just place 4 in the place of second index, 8 in the place of fourth index, and so on and so forth, and at the place of last index you would just place 2. So like you would kind of cyclically shift at one place, so that you maintain the cycle structure as well as you do not end up with fixed. So this is the solution of this problem. The time complexity ends up being n log n due to this step itself, and n log n of c also. So I hope this question is clear. Okay. So now moving on to the second question. Yeah, so the second problem is non-prime tree. It is also a small problem statement. Before this, I would suggest that you are aware with the complexities of tree and and some theories regarding it. Although all the theories are simple only for this problem, but I would suggest you have a basic idea of trees. So in this problem, we are given a tree, and we need to place a number at each node. We need to construct an array, and that would be a number that would represent the number that we are placing at that node. And at the end, we need to satisfy this condition that modulus of a ui minus a vi is not a prime number. Like for each edge, the absolute difference of the nodes at both ends of the edges is non-prime, like it is composite. So the problem statement is simple. I hope you have tried it, and let's move. So in this problem there are like many constructions. I would just show one construction here, and so the first thing, like I also gave a similar problem in the constructive lectures too. So it was the problem where we needed to like use XOR v does not have to be prime. It was that problem. Does have to be prime. So it uses a similar idea here. So basically the idea is in this construction that if you place like the absolute difference of two even numbers is even. So and the only even prime number is 2, right? So what we are trying to do here is even like we would like to place even numbers on each of the nodes, so that like let's say here is 4 and here let's say 8, so the difference ends up being 4, and the only case we have to worry about is when there is n and n plus 2, like or x plus 2, whatever. So that difference ends up being, so in this case difference ends up being prime. So this is what we are trying to achieve here. So one construction that I would suggest in this problem, how you could approach it is just try a lot of constructions. Just see what the problem is in your current approach and try and fix it with some modification to the construction set. Or you could, so I would like to show one construction here. So let's say this is your tree. Okay. So in this case, what I'd like to say is we are placing only even numbers, right? So 2, 4, 2n minus 2, 2n. So one construction here is that you could just you could just perform DFS on the tree, like BFS on the tree, breadth first search, and at each level you could just place you could just place numbers like this, like you would place 2 here, then 2n here, 2n minus 2 here. Like you could, like from numbers from 2 to even numbers from 2 to 2n, you could just place numbers starting from the front of the array at even depths and starting from the back of the array with odd depths. So what this would help is, like here I would say there are 1, 2, 3, 4, 9 nodes, right? There are 9 nodes here. So I would place numbers from 2 to 18. So in this case I would place here 18. I would, let me erase it. So I would place 16 here, 14 here, and I would place 4 here, 4 here, 6 here, 8 here, 10 here, 12. So you would just see that it is kind of like 2 pointers, like one is starting from front, one is starting from back, and at the end where we will have an issue is like whenever the difference is 2, we'll have an issue, and you could prove it that would happen at only one place, and one of those nodes will be a leaf, because it would happen at one of those node would be a leaf. So to deal with it, you could just increase the index at leaf by 1, so that the difference just ends up being 1 and 1 is not a prime. So why can we, and you'd think that why can we not just increase the index at the other node, right? It is mainly because the other node would affect the nodes which are joined to, which are like attached to it, like other children's or its parent, right? So you could end up having a case where the difference ends up being 3 or 5 or something like that, or some other prime. So so you could just increase the value of leaf here by 1, and you'd be just good to go, and this construction would be just valid, right? So this is so a thing to note here is that generally the solution to these constructive problems is quite simple and easy to implement, and just try not to complicate it. Just start with a basic construction, simpler construction, and keep on improving the ideas around it. So I hope this question is clear. If you have any questions, you could post it into the chat, and let's move on to the other question. Okay, so this is an interactive problem. I hope you have read it and tried it. If not, then I think you should pause and try it again. So the basically interactive problems are generally constructive problems only, because you just have to come up with an algo to ask the queries. There is no fixed rule about it. So the problem here states that Blackslax lives on an island which is represented by an n cross n matrix, and exactly one penguin was at each grid, and he had labeled that penguin from 1 to n square. After some time, the grid kind of shuffled because penguin migrated, and he needs the current position of the penguin. So so we ask queries of the form I comma j, where in the new grid we are reported with the Manhattan distance between penguin I to penguin j in the grid. So, and we can ask almost 3n square plus 150 queries to figure out the positions of, to figure out how the new grid looks like after the migration and all. So let's get into it. Also do note that the constraints here are small, like n is up to 100 only, and let's get into it. So I would suggest, like, you look here using like, you try to formalize it a bit, like write your observations and just formalize, like just write the equations of how you are thinking and what all maths you are using, right? So in this position, what you would prefer, like you are asking 3n square queries, right? So you wouldn't want to ask random queries about random I and j, right? So you would want to fix an I at some place on the grid and ask the queries to all the penguins around it, so that you could, if you know this position, you would get a rough estimate of how far that is, right? So a good thing here would be to just use one of the corner penguin and ask the distance to all the nodes using this penguin itself, because now you would know these are in this part of the grid only. So you would just, so for each particular penguin, you would know which diagonal that penguin lies in, because whenever you go up a diagonal, you just change the Manhattan distance you increase the Manhattan distance by 1, right? So in this case, your main idea would be to just ask from one corner and go ahead. So how would you find that corner? Suppose you start from a random penguin and ask the distance to all other penguins, all the n square penguins. So it would just take you n square minus 1 query, right? Because you know the distance yourself, obviously. So what it would do is, you would just so you would get the distance to all the penguins. So what you need to figure out at the end is, you need a corner, right? So it would be fairly intuitive to see that the farthest distance to this node to the random penguin would be at one of the corners, right? So you could just sort the distance and find the maximum value, or just find the maximum value in a single pass and find and figure out the corner, which penguin number is at a corner. You wouldn't know that it is this corner or this corner or this corner or this corner, but you would get a fair idea that which corner it is. That it is that you would know for sure it is a corner. And also, according to the problem, you can, like, there could be multiple solutions, but the thing is that, like, let me read it again. Like at the end, what you need to print is that you need to print a grid such that this condition holds. So this condition would hold even if you take the transpose or flip the grid, but do not change the orientation of penguins, like the relative positions of the penguin. Then you would be good to go. So you could just assume it is at one of the corners. So you could just assume that it is at one of the corners. Let's say using the first n square minus 1 queries, you get this, right? You get this one of the corners, and let's say this is that random node, and you get distance from this corner to all of the other ones, and now you could just query all the penguins related to this corner, right? So you would just use your another n square minus 2 queries and you would end up with the distance from this corner and the distance from this random point itself. So I would like you to think that how would you, like, let's say a penguin attacked is at x comma y, right? So you need to find x comma y of a penguin. So could you find it using just these two? It would be fairly hard, right? Because you don't know the relative orientation. You just know that this corner is farthest from this one. So it could be here, anywhere, right? It could be at any diagonal. So a thing that to note here is, if you take another corner, like non-opposite corner, so you could find out the coordinates to this one fairly easily. Like, let's say this corner would be 1 comma 1, right? And this corner would be 1 comma n. Like, sorry, n comma 1. So when you, suppose after you have all the distances from this corner too, so it would be d2 from here and d1 from here. So you would just figure out that using the Manhattan equation formula, you would just figure out that d1 is basically x minus 1 plus y minus 1, and d2 is basically x minus n. So the distance would be just x minus n from here, and y minus 1 from here, right? So you would know that this x is lesser than n, so d1 would just open like x plus y minus 2, and d2 would just open like x plus y minus n, like not x plus y, rather n minus x plus y minus 1, right? So you could just solve these two equations. and get the x comma y for each of these in the general form. So this is how you could just, so like let's analyze how you would find the other corner. So for the other corner, right now you have distances from this corner and you have distances from let's say some random block here. So you know that if it is a corner of here or here, it could be either corner, it would work just fine. So you just figure out like the distance from this corner to this corner would be n minus 1, right? So from the other so you could easily get all the nodes which are at this diagonal easily using this formula, like just by finding all the nodes which are at a distance of n minus 1 from this corner. So to just find another corner, you would just you already have the distances from this random block, right? So you could just figure out which one of the distances farthest from this one and also lies on this diagonal. So you would among all the nodes that lie on this diagonal, you would check which is the farthest to the random block, right? So you would end up with one of the corners. So a case that could happen is when like the random block you figured out ended up being this corner itself. In this case, what you could do is you would just take an integer like a penguin from this diagonal, and you could just find the relative distance to all the other penguins on the same diagonal itself. What it would tell you is the penguin with the farthest distance from this one is the opposite block, right? So you would just end up spending another n minus 1 queries to find the block and another n square queries with finding the node, right? For finding each of the value of d2 and then solving the equations. So at the end you would just end up solving it with 3n square plus n, approximately these many queries, and you could easily reduce it by just checking you are not asking the same query twice. So you could so the main thing here was just manipulating the equations which you had. Like you could just, if you were able to formalize this d1 and d2, then it was pretty straightforward that these are just easily solvable, and you just need to find the opposite corner you just had to check the relative distance, right? And this is what we had done for the other corner too. And I hope this is clear. If you have any doubt, you could post it in the comments. Now I think you should move to the final question. Okay, so I really hope you have tried this problem, because it is a good problem and it is good to at least give it a thought. So in this problem, this is also interactive, and in this problem you have n identical boxes. Each has a hidden value of either 1 or 2, and here you have two type of queries. One is swap or the other is throw. So when you give swap x, the boxes at x and x plus 1, they change, and this change does affect the future queries. And when you give the query throw, you throw a ball from the coordinate x that you had given, and the ball and for each coordinate x it would travel p units, which is the power unit of that blocks, or whatever the value it was in that blocks, that is 1 or 2, and you jump by that coordinate. You jump to x. If you are at x, you go to x plus p, and it just continues forever till the ball just goes out, right? Goes out of n. So So after 3n/2 queries, you need to figure out what is the array of the what is the hidden array. So in this problem, what we are trying to do is we need to manipulate the array using two queries and using two types of query, and all the queries have to be less than 3n/2. So let's see how we can do. So one of the thing here is that you should try thinking about it from the back side of the array. Why do I say so? Because from the front side of array, there are a lot of things which are affecting the values in the front. Because like the whole array ends up affecting the values which is at the first index. So if you do a throw query from index 1, you would have to visit like at least n/2 indices. So that could be very troublesome to think about. So I would suggest you go from the backside of the array, and also I hope you noted that in the throw query you are given with the total number of jumps that the ball has made before stopping. Okay. So from the backside of the array, what can we do is we could, first of all, it would be obviously better to figure out how many jumps it takes for each index to reach the end, right? We need to find the throw for each index, right? So one of the method is just to naively query throw values, but you would be just left with n/2 more queries to figure out all the values now. So we would want to minimize those, right? So one of the things is that suppose ti is the number of throws it takes at the ith index. So if ti plus 1 is equals to ti plus 2, we could just figure out that ti is basically 1 plus ti plus 1, right? Because like no matter what value is at the ith index, it would either jump at ti plus 1 or either jump at ti plus 2, and since both the values at ti plus 1 and ti plus 2 are same, it would our answer would, the value of ti would just be 1 plus any of them, right? So another observation that we could draw here is suppose in this case where ti is not equal to ti plus 2, right? ti plus 1 is not equal to ti plus 2. Like we are iterating from the back of the array, right, in the reverse. So if ti plus 1 is not equal to ti plus 2, we would just query the value of ti, and by the value of ti we could just see that it is, if ti is 1 plus ti plus 1, then the value of ai has to be 1, because it must have jumped to the index I plus 1 only, otherwise like the number of moves would not satisfy, right? Else ai would just be 2, right? Because it is only 1 or 2. So we could determine ai if ti is not equal to ti plus 1. We could determine ti minus 1. We could determine I minus 1. And if ti is equals to ti plus 1, we can determine ti we could determine ti minus 1 only, but cannot determine the ai. But we cannot determine ai, and also we would be left with an extra query, like we would not use query here. So till now, how many queries we have used? We have used query equal to the number of nodes, right? We have used exactly these many queries. So because like whenever we are querying, we just end up getting like whenever we are querying, we just end up knowing the value itself, right? Otherwise, if we are not querying, then it is only this condition only. Otherwise, we just know the value. So so another thing that I would like to say here is the number of moves here, like ti, like it could never happen that three values are equal, right? So there could be at most, so like this type of condition cannot, I write it neatly. Like ti is equals to ti plus. So this type of condition would not happen, right? Because if you are at ti, you would either jump at ti plus 1 or ti plus 2. So you would obviously be more than either ti plus 1 or ti plus 2. So now we are left with indices I such that ti plus 1 is equals to ti plus 2. So what can we do for these indices? We could just, for these indices, we could just swap I and I plus 1. Then we know that that the condition that ti plus 1 and ti plus 2 and ti plus 3 are equal cannot happen. Like three consecutive values cannot be equal. So we could just swap I and I plus 1 and then end up throw from I plus 1. Like the box at index I would now shift to I plus 1, and if we throw from I plus 1, we would just know that if it is equal to ti plus 2, then the value would be 1. If it is equal to 1 plus ti plus 3, then the value would be 2, because it would jump to either one. So for these, so how many queries do we end up using? We use one query for every for those where ti is not equal to ti plus 1, where ti plus 2 is not equal to ti plus 1, and two queries where ti plus 1 is equals to ti plus 2. And we have already proven that this condition cannot happen consecutively. Like happening consecutively means ti plus 1 is equal to ti plus 2 and ti is equal to ti plus 2. We have already proven that these two conditions cannot hold simultaneously. So it would just mean that so in the worst case, the maximum number of indices that would use two queries is basically n by 2, right? Is basically the seal of n by 2. So at the end, how many queries do we have? We have 1 into n minus n by 2. These are the indices where we do not have a query. These are the indices where we could just find using this condition itself, and plus we are using 2 times n by 2, like an extra, like an extra query for whenever, we are using two queries whenever this condition holds. One is swap and other one is throw. So at the end, the number of queries we end up using in all is basically n plus n by 2, or 3n by 2, right? So I hope this is also clear. Right. And when it comes to implementation, you could even implement an n square algorithm if you could think of. But the O of n algorithm is fairly obvious to implement now that I have told the solution. So I hope all the solutions are clear, and I hope you just keep improving by the methods that we have mentioned in the previous lecture, and keep practicing more problems regarding this. and hope to see you in ICPC contest.